Let's go through LeetCode 863 all nodes distance k in binary tree. For this question, it gives us a binary tree and also to give us a target node and let us to find all of the nodes which have the distance k to the target node, and return the list of integer will be those kind of nodes values, because it says that the nodes value are Unix, so we just return the list of integer. We'll see for this kind of question, it has a target node is 5 and k equals 2. So you'll see 7 and 4. They have the distance to 5 will be 2. The thing that this kind of node, it can go to the root and go to the other branch. So the thing that it's not just go to its child, it can also go up. So for this target node, it has 3 kind of directions. So what we can think about is that we can convert the tree to a graph, and we BFS the graph to find the nodes. So let's begin to write code. First is that we want to convert the tree to the graph. So let's use a map to represent a graph. We'll have a tree node and have a list tree node graph. First new hash node. We're going to use the DFS to compose graph from tree. So we'll have root. For this kind of root, I'm going to pass another variable. For that is every node, it will have if there is a parent. I'm going to put the second variable as a parent. For the root, does not have any parent node. So let's say I'm going to pass a none here in the graph. So let's write the DFS function to compose a graph. Node parent, and also tree node list tree node. So let's say we are going to create if let's say if this graph contains this key with this node, since that if it does not contain, we are going to create a list first to put a key value pair to it, and also we are going to do 3 things. One is that trying to see whether the parent is null or not. If it's not null, we're going to add parents to this list, and then we're trying to see whether this node has left the child equals null or not. If it's not null, we are going to put the left child to this node and then the right child. So let's begin to write code for this. Let's say if graph button contains key, right? Not. I'm going to have graph put not new array list. And we are going to put if this parent is parent is not null, right? If the parent can equal to null, we're going to put the parent to this list. I'm going to have a list first. List tree node list equals graph it node list like parent. Also, we are going to have if node at the left that's not equal to null, we are going to do is that paste add a node at the left. And also we are going to DFS for the left child, that is DFS node dot left. And now the parent will be the node and will be the graph. And I will say if it's node dot right, that's not equal to null. Our list add node dot right. And also DFS node dot right node graph. So after this DFS, we compose the graph for this tree and compose a graph from this tree. And then what we need is that we have the target, right? And we are going to, from this target, we consider that target is start. We can do BFS and try to find the k distance nodes. So for BFS, we are going to use a Q tree node Q equals to new array. Yeah. Because now it's not a tree. Again, it is already a graph. So for graph, we do BFS. We need to have a set, right? As a valid. And if we don't use set, we can also, because the value of the tree node that is unique, we can also have create array for the to keep things simple. We just have the set here. Probability, it's new hash bet. We're going to have to offer target. We'll start from target and ability at target. So BFS while Q is not empty. We need to have a size here because we want to find the distance. For int I equals 0, and smaller than size. We are going to have the k minus minus. Let's create the result here. List integer result equals new array list. let's say tree node equals q dot pro. Here if k equals 0, that means the distance we already get to this k. Then we're going to have a result at node of value. And therefore, tree node will find its child, right? In node but map it node. But for graph, we want to check is that whether the visit set contains this child. If visit contains child, continue. Then we're going to have Q of child and visit at child. And then after that we return result. Graph, there is no graph. Okay. Doing like this way, we iterate do BFS and DFS. We iterate the whole tree, and the time complexity will be O(n).